I wanted to show you something that relates to what we've just been talking about here. I've got this application called Wireshark. Some of you may know of it, some of you may not. But basically, it's a free of charge protocol analyzer that captures Ethernet frames. And I'm going to open up a file here. And this file that I'm going to grab here is a capture of Ethernet frames on the wire between two voice over IP phones. So what I'm going to do is come over here, and I have the file that I captured previously, and I'm going to put in here a filter for real-time transport protocol, and then we're going to see that that's the protocol for all these different multiple packets. We have the Ethernet frame here, and these are multiple packets. This is the highlighted one that's shown down here. And if I want to open up this, I can look inside here. And what I want you to relate to what I'm looking at, excuse me, forget that. What I want you to relate to, what you're looking at right here, is the OSI reference model, because what you're looking at is effectively that OSI model. Here's the layer 2 Ethernet header, and in it is the source and destination hardware address. It's going to a Cisco device. And this is the hexadecimal hardware address of the destination. There's the hexadecimal hardware address of the source, the voice over IP phone that it came from. And then I told you there inside the Ethernet header was a type field. And here we have a type of 0x, which means that the number you're about to read is in hexadecimal format, 800. And what that means is that this Ethernet contents is IP, so that the recipient of this Ethernet frame can say, hey, the content of this Ethernet frame is IP, because it has a hexadecimal value of 0800. We can then, if we're receiving this, we can strip off the Ethernet header and send it to IP for processing. Inside the IP header, we notice that we have a source and a destination IP address, along with a lot of other things that we're not going to discuss at this moment. But we have a source and a destination IP address inside the IP header, as we discussed in the OSI discussion, so that we can send this packet route it throughout the World Wide Web. We also notice that we have a protocol field here. That protocol field is much like the Ether type field, and if it has a hexadecimal value of 11, that indicates to the recipient of this IP payload that the contents of it is UDP, or User Datagram Protocol, UDP. And sure enough, look at that. That's the next header. So if we shrink that down, we open up UDP, and we can see that UDP has these things called port numbers. Remember, I told you that port number is nothing more than a 16-bit field. These two devices, the voice over IP devices that are in conversation here, had to agree. The receiver says, okay, send to me on port number 16,406. And so that when it receives this UDP payload, and it has a port number of 16,406, it can say to itself, hey, that's the port number that I agreed to receive voice over IP on, so let's go ahead and strip off the UDP header and send it up to the application for processing. I know that 16,406 is RTP, so I strip off the UDP header and send it to RTP. This is the application header RTP. It's 12 bytes, of which we'll not go into the details here, but the main thing that I want you to notice here is the actual payload. Eventually we drill down far enough, we get into a payload here that's displayed here in hexadecimal. This is actually the sound of someone's voice that has been digitized, that's being sent across the network. This was taken, this payload, and had an RTP application itself, put a 12-byte header on it, then shoved that into a UDP header, took the UDP header and the real-time transport header and put that into an IP header, took it and shoved it into an Ethernet frame, and then shipped that to its destination. You notice we captured this down at the bottom on the wire. So you notice that the OSI model here is sort of backwards from the way we've been looking at it. Layer 2, Layer 3, Layer 4, application layer. Now TCP/IP is the protocol that we're looking at here. Was around long before the OSI model, not long, but it was around, well, 15 years before the OSI model came out. So therefore, it doesn't have all 7 layers. However, it does all 7 layer functions within these few layers that you're looking at right here. So when you see this, think of the OSI reference model. When you think of the OSI reference model, think of this. Okay, so that's what we're looking at. That's packet 1, packet 2, and packet 3, and so on. So this just down here in this window on the bottom happens to be the hexadecimal representation. It's just another way of looking at it. And then over here on this field over here, we have a ASCII way of, in case it happens to be an email, we could actually read it over here. So I just wanted to show that to you. And, you know, again, this is the OSI model, and these are the components. We won't go into the details of these until much, much later.